Welcome. This is an exercise in a one-way between groups analysis of variance, or ANOVA in SPSS. To run an analysis of variance, we want to have one independent variable, which is at the nominal level, and we want to make sure that it has 3 or more levels. If the independent variable only has 2 levels, then the appropriate test to run would be a t-test. Also, for an ANOVA, we want to make sure that the dependent variable is at the ratio or interval level, which are both forms of continuous variables. In running an ANOVA, or the reason we want to run an ANOVA, is to make inferences about whether or not groups have equal means in the population. Okay, so in looking at the SPSS file, we can see our 2 variables. We can see our dependent variable comp here, which is comprehension, and our independent variable group. If we go down to the bottom of the screen, we see that we're in data view. We can click on variable view to see how many levels of our independent variable that we have. If we look at our independent variable group here, we can go over here to values and click on that. We see here we have 5 levels of the independent variable, or 5 different groups: reading, oral, writing, storyboard, and discussion. Okay. But prior to running our analyses, we need to state our null and alternative hypotheses. So if we go to the board that has magically erased and someone's came and magically written something on it, we see the null hypothesis denoted by H0 here. So the null hypothesis for this data set is, in the population, all presentation styles have equal mean comprehension scores. Okay? The alternative hypothesis, which is denoted by H sub A, is, in the population, there is some inequality among presentation style groups' mean comprehension scores. Also, prior to running our ANOVA, we need to see if the assumptions for the test have been met. Now, assumptions are preconditions for meaningful use, and we need to test to see whether our assumptions have been met. The assumptions for a one-way between groups ANOVA are independence between and within groups, normality, and homogeneity of variance. Now, the assumption of independence requires that the samples for each group are randomly selected from the population, and it requires that the sample selected for one group has no bearing on the sample selected for other groups. If the assumption for independence is not met, an ANOVA should not be run at all. However, since we're working with the data set and we have no information about how the data was collected, we'll just take it on good faith that the researchers took this into account when collecting their data. Now, the assumption for normality requires that the scores be normally distributed around the mean on the dependent variable. And we'll check this in SPSS. The assumption of homogeneity of variance requires that the group means have, that the groups have equal variances in the population. And we'll check this in SPSS as well. So let's go ahead and do that right now. All right. To determine if the assumption of normality has been met, we need to run descriptive statistics, a KS test, and look at graphs. So to do this, we'll go to Analyze, Descriptive Statistics, and Explore. We'll want to make sure that our dependent variable is in the dependent list box, because this is the variable we're going to check our assumption of normality about. We also want to make sure that here at Display that we have the Both button checked. Okay. Next, we'll want to click on Plots. When we click on Plots, we'll look under here under Descriptive, and we want to be sure that histogram is checked, because we'll want to look at histogram to form a judgment about the assumption of normality. Also, we'll want to make sure that normality plots with tests is checked. This will make sure that our output will show our probability plots and also our KS tests of normality. After we do that, we'll go ahead and click Continue. Okay. When looking at our output, we'll first start by looking at the descriptives box here. In looking at the descriptives box, we can see our measures of central tendency, such as the mean here and the median here. we'll want to look at the mean, which is 9.94, and the median, which is 10. Because in a normal distribution, or in any symmetrical distribution, measures of central tendency, such as the mean, median, and mode, are theoretically equal. Here, we see that the mean and the median, the mean and the median are pretty similar, suggesting that the distribution is symmetrical. We can also look at our skewness value here, which is 0.125, which suggests, because it's a positive value, there might be some problems with positive skewness. But if we look at that value relative to its standard error, positive skewness may not be a big problem. If we scroll down a little bit more in our output, we can look at tests of normality. In this table, we see our KS tests. If we look at the significance value for the KS tests, we see that the value is 0.200. Because this value exceeds the traditional cutoff alpha value of 0.05, we can go ahead and retain the null hypothesis and assume that the assumption of normality is met within the population. Okay. Again, as we stroll down our output more, we begin to see our graphs. Here, we can see this histogram. And looking at the histogram, we can see some abnormality with the left side of the distribution being heavier than the right, which suggests slight positive skewness. But overall, the distribution looks pretty symmetrical and pretty unimodal. Additionally, we can keep going down and look at our probability plot. In this case, the QQ plot. What we're looking for here is a snake-like pattern around the line to suggest deviation from normality. In this example, the points hug pretty closely to the line of best fit, suggesting that the distribution doesn't deviate too far from normality. All told, the distributions and statistics so far don't suggest that violation of normality is a big problem. Finally, to determine if the assumption of homogeneity of variance has been met, we need to actually run our ANOVA. And we will look at the results bearing on the assumption prior to looking at the results of the ANOVA itself. All right, so we'll go back to our data file. And to run our ANOVA, to actually run our ANOVA, we'll go to Analyze, General Linear Model, Univariate. We'll want to make sure our dependent variable, in this case comp, is in the dependent variable box. We'll want to make sure that our independent variable group is in the fixed factor box. Okay. We'll want to click on plots here, and we'll want to move our independent variable group over to the horizontal axis box, and then click Add. And we'll see it says Group down here. This will provide us with a graph of our marginal means, so we can visually see the results. Next, we'll click on Continue. Thank you for joining us, and happy SPSS.
That's messed up.
What I want to like.
Any decision I've ever
Chula Vista High School.
Really just knowing
there are certain faculty
And I got
that I've gotten
and suited her back
when I was living back
and to do maybe we
made in life. I looking back home in Canada.
bachelor's.
to know very well.
And then they came out with
the people that not